Hey there, class. Mr. Pusky here. Hope you're having a good day so far. Today we're continuing chapter 5. We're talking about medians and altitudes today. We're going to be talking about centroid, orthocenter, two more measures of center for a triangle. And it's going to be a good time. So our name of this lesson is use medians and altitudes. Our essential question is describe how we use medians to solve for triangle lengths. All right, we have a warm up here. It says, for what value of x does P lie in the bisector of angle A? This is an example from 5.3. We're looking at if this is on, oops, that was bad. If this is on the bisector, what do we know about these lengths right here? We know something about those lengths. See if you can figure it out. Go ahead. All right, if we know that that's on the angle bisector, we know that these are congruent. So if they're congruent, what are we going to do with them? We're going to set them equal. So we have 3x minus 9 equals x plus 3. We're going to solve for x, subtract x from both sides. 2x minus 9 equals 3. Now what? Add 9. We get 2x. 3 plus 9 is going to be 12. Divide by 2. And x equals 6. And if we're looking for what value of x, what we're looking for. So that's our final answer. Okay, sounds good. Let's get into some definitions now. So the median of a triangle, say median, a segment that connects a vertex to the midpoint. To the what? Midpoint of the opposite side of a triangle. So I'm going to draw a triangle over here to kind of help you visualize this a little bit. All right. So we have a triangle there. Okay. So basically, it's going to go from, what does vertex mean? That's a corner, and it's going to go to the opposite side. So say this is the midpoint over here. This is the median. It goes from the corner to the midpoint of the opposite side. Okay? That is a median. Let's put median up here. All right? From the corner to a midpoint of the opposite side. And the measures of center, the point of concurrency, which is where all the medians intersect. It's the point of concurrency of the three medians of a triangle. The three what? Medians. Okay. And a cool thing about the centroid is that it's actually the center of gravity of a triangle. So if you have like a piece of wood that's shaped like a triangle and you find the centroid on that piece of wood, you can actually balance it on the tip of a pencil or like an eraser or something. It's pretty cool. It's basically like the center of gravity. So basically all the mass is evenly distributed and they can balance. Okay, let's talk about altitude now. Altitude of a triangle is the perpendicular segment from a vertex, from a what? Vertex to the opposite side or to the line that contains the opposite side. So let's draw some altitudes here. So we'll draw the same triangle here, okay? So an altitude can be from the vertex, which is the corner, down at a right angle to the other side. Okay, this is an altitude. Or, one thing about altitude is that most of these other things have to be inside the triangle, but if we have like an obtuse triangle like this, you can actually have like the right angle at a perpendicular angle down. It's actually going to be outside the triangle like this. So that's an altitude. So this is an altitude and this is an altitude, okay? It's kind of weird, but that is the case. You can have an altitude that's outside the triangle because it needs to go at a right angle to the other side. And if that corner of the triangle is like kind of leaning past this line right here, then it's going to be outside the triangle. Okay, and the point of concurrency of a triangle with altitudes is where the altitudes intersect. And this is actually one of the weird things is that it's called the orthocenter. Say orthocenter. The orthocenter can actually be outside the triangle as well. Okay, because the altitudes can be outside the triangle. All right, now this part's a little weird, but it's kind of it's not too bad once you think about it a little bit. Okay, so if you take a median here, so say BF right here. Yeah, actually, let's talk about So BF, right? So where the centroid intersects in the middle here. This is going to be 1/3. It's actually going to be x. This is going to be 2x. Or it's going to be 2/3 and 1/3. Okay, so basically 2/3 of the length is going to be BP to to the corner, and then one third of the length, or like x, is going to be from the centroid to the other side. Okay, it's kind of weird, but we'll do some examples and it'll make a little bit more sense here. So AP equals 2/3 of the entire length, which is AE, or 2x, okay? BP is 2/3 of BF, the entire length, and CP is 2/3 of CB, okay? So I like the 2x and x thing. I think it makes things a little bit easier. But like basically, like, yeah, 2/3 of the distance is from the corner to the center, and 1/3 of it is from the center to the or the centroid to the side. Okay. All right, and then altitudes of a triangle, they are concurrent. They are what? Concurrent, and that just means they intersect. Okay. All right, let's do an example here, because these are kind of weird. All right. So let's change the color. All right, so it says use the centroid of a triangle. If in triangle FGH, M is the centroid and GM is 6. And we want to find ML and GL. Okay, so is GM, is that 2x or x? Is that 2/3 of this length, or is it 1/3? This is going to be 2/3. This is going to be 2x. This is going to be x. Okay, so if we set it equal to what we know, 2x equals 6, right? How do we solve for x now? We're going to divide by 2. And x equals, what's 6 divided by 2? So x equals 3, and that's ML, right? So ML equals 3. And then how about the entire length? What would GL be? Well, GL is going to equal 6 plus 3, right? So we got 6 plus 3, which equals what? It equals 9. So we have 9 and we have 3 is going to be our answer for that one. Okay? All right. Yeah, so basically the entire length, if you think the entire thing is 3x, and then 2/3 of 3x would be 2x, and 1/3 of 3x would be 1x. Okay? All right, same thing. It says example, it's a checkpoint. Example 1 is suppose FM is 10, find MK and FK. Why don't you guys pause the video and see how you do. Use a different color here. Okay, so FM is 10, okay? So FM is 10. Is that the 2x or the 1x? That's a 2x. We have 2x equals 10. How do we solve for x now? Divide by 2. X equals, what's 10 divided by 2? It is 5. Okay? So that means that MK equals 5, right? And what would FK be? What would the whole thing be? We would have 10 plus 5, which equals what? It equals 10. Actually, 15. 10 plus 5 is 15. My bad. All right, and there we go. Okay. All right. Example 2, I don't like all that much, but we can go through it anyways. No worries. So, find the centroid of a triangle. We're looking for, we had the vertices of this triangle. So we had J is 1, 2. Where do I go to graph 1, 2? Right 1 up 2. How about, and this is J. How about 4, 6? Right 4 up 6. Okay, that is K. And how about L? 7, 4. Right 7. And up 4. And that's L. Okay, so this is the triangle right here. All right, sounds good. And we are looking for the centroid of JKL. So, remember, the centroid is dealing with medians. We're going to do a median here. Probably the best median is from K to the other side. You can see that's going to make these congruent, right? So if we're looking for the centroid, we got to put a dot somewhere on that line. Is it going to be up by K, or is it going to be down toward the other side? Well, if you recall, so let's call this M here, right? So K, well, let's see here. So basically, the centroid is going to be 2/3 of the way from K to the M to the other side, and 1/3 of the way from the centroid to the other side. So it's actually going to be right here, because this would be 2 boxes. This would be 1 box. That's going to be our centroid, which is going to be 4, 4. All right, and that is it. That is the centroid. And that example is not that great, but just want to go through it anyways. So, all right, last thing I want to show here. So you have access to it. This is an example of like all the things we've covered from 5.1 through 5.4, mostly 5.2 through 5.4, with the perpendicular bisectors and circumcenter, angle bisectors and incenter, median and centroid, and altitude and orthocenter. And it has some different drawings here to help you visualize what's happening. And for example, centroid, it shows the 2/3 and 1/3 thing. So it's kind of helpful graphic if you'd like to refer to that. So, okay, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.